Okay, today our topic is 2K graphing functions. Let's look at the difference between sketch and draw. If we are asked to sketch a function, it will show the graph's general shape and its key features. If we are asked to draw a function, it should be done more carefully to scale. Or we can say sketch is a rough graph, but draw should be a nice graph. The key features of a graph of a function should involve: the first one is the axes intercepts, including x-intercept, y-intercepts. Turning points, which could be a local minimum or local maximum. Values of x for which the function does not exist. Those x values are undefined values. The undefined values also produce the vertical asymptotes. The last one we need to look for are the asymptotes, including vertical asymptotes and the horizontal asymptotes, which are lines or curves that the graph approaches. So right now, we need to look at this example 1. In example 1, you look at this function. This is a rational function, but the top is a quadratic function, the bottom is a cubic function. Then you divide them n+3. This is a very complex one. Use the graphing calculator to help answer the following questions: the x-intercepts, turning points, asymptotes, domain and range, then sketch. So let's put the function into the graphing calculator. So here, I have the function put in already. But when you put in the function, make sure, okay, you can put the pair of brackets for the top and a pair of brackets for the bottom and divide them, then +3. My window setting will be x minimum equals -5, x maximum equals 5. And in most cases, we want this unit scale on the x-axis be 1. Y minimum, I can choose -5, y maximum 5, and y as C1 is 1. So let's see the graph. Okay, you can copy this graph onto your paper. For me, here, I will just take a picture from the graphing calculator. So let's enlarge the graph. We can see that this is the y-intercept. The x-intercept is here. It seems the graphing calculator does not show us the entire graph, but we need to use our existing knowledge to figure out. There is a vertical line here. This vertical line shows me the vertical asymptote. So that means this part of the curve should go down forever, and getting closer to the vertical asymptote but never cross. Anyway, let's use the graphing calculator to find the y-intercept first. How can we find the y-intercept? Let's go to second trace. I choose value and put a 0 in. So the graphing calculator will give me the y-intercept value, which is 2.1666. Anyway, all the way goes on forever. So what we will do is we only need 3 significant figures for the y-intercept. The y-intercept is 2.17. How about the x-intercept? This is a tough one. Since we are not able to see the graph crossing the x-axis, I have to use zoom in. So let's zoom in the part which is on the x-axis. So I wanted this part. So let's enter. Okay, so the graphing calculator will show us such a kind of graph. Here, this is the x-intercept. So how can I find this x-intercept? So let's go to second trace. X-intercept is the 0. Let's find the 0. Okay, left bound. Let's look at where is the flashing cursor. Okay, it's here. So on the left side of the x-intercept, it's almost there. Let's enter. So then move the flashing cursor to the right side. It's almost there. Let's guess. So the 0 point, which is the x-intercept, is around 1.04. Okay, this time we need to figure out the turning points. The turning points can be the local minimum or local maximum. So we want to go back to the normal function graph. So I change the window setting here again. I will go back to -5 to +5. Then y minimum is -5 to +5. Let's graph the function again. Okay, you will see there is a local minimum here, definitely. Let's find the local minimum from the graphing calculator. So we use second trace minimum. So we move the flashing cursor to the left side of the minimum point. If it's around there, we press enter. Then we move this flashing cursor to the right side of the minimum point. If it's almost there, let's press enter. Then guess. Okay, this is the minimum point. Okay, we put on the coordinates for local minimum. So the x value is around -1.88. The y value is around 0.788 on your graphing calculator. And I found that this right part look like there is a local maximum point. It's a peak, or maybe it's around here. Okay, so anyways, let's use the graphing calculator to help us. So it's second trace, go to maximum. If you are not able to determine, or we can say you are not able to see where the local maximum point is, you can leave this one on the left side of the maximum point a little bit further. That's okay. So let's press enter. Then we move this one to the right bound. Since we don't know the exact position for the maximum value. So what I will do is I will move this cursor and see the y value here until, and this one is still, let's go back. You will see this one is pretty large, and then it's getting smaller and smaller. So then I can estimate the maximum point is around here. So what I will do is I press enter right now. I guess. Okay, so that's what I can find from the graphing calculator. So the local maximum point is x value is around 4.00, right? Because we need to keep 3 significant figures. And the y value is around 3.68. Okay, we find the local minimum, the local maximum. The next step is, let's look at if there are any asymptotes of the function. We can find the vertical asymptote, definitely. So the vertical asymptote is also the undefined value in the function. And we can see this one is x equals 1. So for x equals 1, this part of the graph is getting closer to the vertical asymptote but never cross it. And this part is getting closer to the vertical asymptote but never cross it. And we find that we also have a horizontal asymptote. This horizontal asymptote is around here. You will see the y value here. If you continue to move the flashing cursor to the far right, you will see this value. Right now we only shows x equals 5. If you change the x maximum to 50, probably you can see more clearly. So look at this y value is almost getting closer to 1 value. This value is y equals 3. So the horizontal asymptote is y equals 3. If you cannot understand this one, what we can do is I do second trace. I will repeat the maximum value here again. Okay, let's just look at, anyway, if we go down, you will see this y value is getting less and less and less. Let's look at how less the y value will be. Okay, anyway, the y value is getting less. If we still cannot see the y value is getting 3, you can change the Windows setting to almost 500. Okay, let's graph this one again. Oh, this one is so clear right now. Look at, there is a horizontal line afterwards. So this horizontal line is y equals 3. Okay, that's how we can use the graphing calculator to find the asymptotes. Then D, we need to look for the domain. With the vertical asymptote, the domain will be very clear. So the domain will be, x can be all real numbers, but except 1. X cannot be 1. And the range, if you look at this graph, you will see the y value can go up infinitely. And here, the blue part can go down forever. So the range will be, y can be all real numbers. So for the sketch, you can sketch these two curves on your paper and show us some key points. Like the local minimum, we label this local minimum point as negative 1.88, 0.788. And we label this y-intercept point as 2.17. We label this x-intercept point as 1.040. And we labeled the maximum point around here as 4.00. Y value is around 3.68. Then we will show the horizontal asymptote y equals 3 and the vertical asymptote x equals 1. So in this case, my graph, or we can say my sketch for the function is complete. Here's the homework. Please let me know if you have any questions.